pleased to welcome Professor Bryan Brooks from Baylor University, who's going to give the first ECORISK 2050 seminar, which is going to be on sustainable environmental quality, lessons learned from the Global Horizon Scanning Project. Bryan.
Well, it's a pleasure to be here with you today, and I think the first and foremost comment I should make is congratulations. So I understand there's 13 Marie Curie Fellows, right, that's part of this project, so that's very exciting because I anticipate over the next few years that you're all going to have a chance to work on your own projects and then also think about coordination among the projects, right? And so you're here, I presume, because you've secured these positions and you're excited about the research that's going on. But I'd like to start with just asking you, why are you actually here? Why are you here? Each individual has their own interests, right? Their own motivations, right? So how are you going to align your interests, your motivations, your talents with the project and the capacity? Now, don't tell some of these professors, but they're actually pretty good. So you guys actually have some pretty good talent around you, right? And then you're in a room full of talented people. So if I think about this in academic recipe terms, we have all the ingredients for something special, especially if you're thinking about what's going to happen over the next few decades in terms of understanding, assessing, and supporting more sustainable management of risks in the environment. So here's the first pop quiz. How many people are familiar with the SDGs? Okay, if you're not, you should take a look, right? Because these are great. Yeah? I try not to use the term "great" these days. It's normal, but everyone, all nations have actually signed on to say that they agree, right? And there's all kinds of wonderful, SDGs like food, energy, and water, right? The food, energy, water nexus now represents a global megatrend. It doesn't matter who's in your Congress in Washington, D.C. or Ottawa or Brussels. These global megatrends are going to continue to shape essentially what happens on this planet going forward. And it's also going to influence what we think about in terms of risks and how we go about assessing them. Because we're interested in climate, climate change is a major issue that's basically permeating and interacting with so many other factors, including things like aquatic and terrestrial systems. Now, if we look at some of these SDGs in more detail, you could look at SDG 12, responsible consumption and production, right? And so we want to achieve, by next year, the environmentally sound management of chemicals and all waste through their life cycle in accordance with agreed international frameworks, and so on and so forth. That's a wonderful goal. And as trainees, you all have your individual goals, don't you? Right? Probably to get a degree and maybe get a position, in gainful employment. What I would try to encourage you to do as you start this process is to enjoy the process. Because the types of things that you're going to be engaging is actually much more interesting and much more actually important in the long run than your individual projects. So you want to think about the interconnectedness among different projects that are going forward. Because it's almost 2020, and this is a great goal that we're not going to achieve. So we need people like you, right? And the work that you're going to engage to help realize this. I like SDG 11. I study cities oftentimes and water and contamination. And so we're talking about sustainable cities and communities. Great goal. So we're going to reduce the per capita adverse impact of cities around the world. It's a great goal, and we've only got 11 years to do it, and we've got to deal with all kinds of waste management. So get ready, fun times in the offing, because right now we realize that pollution is a major global issue. In fact, it's a great and growing problem, according to Bill Landrigan and colleagues' recent Lancet Commission report on pollution and health. And you might even argue that some of the ways that they were able to try to assess the aquatic portions of this were inherently limited by the available information. I might even argue they probably were underestimating the impact of pollution on aquatic systems. So we have grand challenges, right? We have global megatrends. We have lofty and perhaps noble goals like the SDGs. We have major challenges. We have grand challenges. The term grand challenges comes from the Gates Foundation, essentially uses it in the early 2000s. Our national academies in the United States have picked it up for engineering, for health and medicine. But how do you move toward achieving these grand challenges, which are oftentimes blue sky initiatives? They're almost, really big exercises. Well, we think that we should take on horizon scanning approaches. This is basically a public health type of model, right? You're looking at the horizon. You're trying to think not reactively, as we have done so often in the history of environmental science. We chase problems when the problems appear. Rivers burning, stimulate activity in the United States. Unfortunately, you see sometimes real impacts, on biodiversity or human health that stimulates activities. We don't take enough time as scholars, as scientists, as new graduate students to think about the horizon, even though we must think deeply about your individual projects, right? But horizon scanning is important because we have many challenges, and we're trying to align these challenges, to achieve noble goals, and oftentimes resources are very stressed. So getting people together from different backgrounds, from different disciplines can be very useful. So the idea is, can we learn from how other disciplines have actually thought through what are big question exercises, like in conservation biology? And as I was mentioning, we think about environmental toxicology and chemistry and engaging environmental quality research questions. We oftentimes, what's the new hot chemical of the day or chemical class today? What do you hear about all the time?
Microplastics.
Microplastics, absolutely. PFAS, right? Whatever it happens to be, right? There's always something else. There's always something else. There always will be something else. How often do we do that? How often do we think more broadly, more integratively? We know we need answers if we're going to meet these lofty goals, especially at these intersections between environment and health. The real question is, which questions should we be trying to answer as we go forward? So we had this audacious idea. Why don't we all think together? Kind of like what you guys are going to be doing from time to time, and hopefully more times than not, during the course of this project. You're going to have an opportunity to think together. Different projects, different scientific, essentially aims that come together. Because I've found that if you ask scientists and engineers what they think is really important or interesting to them, they'll tell you, right? Because as it turns out, people are passionate about what they're working on. They're very invested. They're engaged. So can we do this in a way that actually is quite structured? So we took some lessons from other societies. Professor Boxall here and I were involved with a project related to pharmaceuticals and personal care products. And quite frankly, the workshop was one of the best that I'd ever attended. And I went up to Gary Yankley with EPA in Berlin in 2012, and I said, Gary, what did you think? He goes, it's the best workshop I ever attended. I said, yeah, me too. We got to do this. We're going to do this across the fields. And then we went over and found Boxall, and yeah, here we go. Let's go have fun. Because we're going to ask people who are working what they think we need to be doing going forward. Now, this is not intended to try to steal anybody's good research idea. This is more like, if you've got research ideas that are really, you think, valuable, what if there were requests for proposals out there that you could send your ideas to, right? Because what we're thinking about is, if we're going to move toward grand challenges, can we actually identify priority research questions that can help us reverse engineer to move toward those grand challenges in a timely, structured, and meaningful way? And so we partnered with the Society of Environmental Toxicology Chemistry for several reasons. They're a great partner. They're international, organized. They are multidisciplinary, and they include multiple stakeholders. Now, in North America, we also had a partnership with the American Chemical Society's Environmental Chemistry and Agrochemicals divisions, which we're really grateful for. So subsequently, what you'll see in the North America paper that's going to come out in August or September is much more robust environmental chemistry, exposure science kinds of research needs, if you're interested in that space. And so, but the key was this process was global, and it was transparent, and it was bottom up, and it was inclusive. And we even took questions from students. Imagine that. I mean, nobody asked me when I was a student what I thought we ought to be trying to study that might actually go into a process that might actually benefit organizations, right, in making funding decisions. And so we use this horizon scanning method where we essentially take a bottom-up exercise, and the social scientists are telling us that, you know, everyone's trying to get to transformational change, right? And every proposal I think I ever read from any country always says that if you fund me, this is transformational science, right? But what we need to be able to do is have good science, right? Credible scientific information. We need to make sure that that's significant to stakeholders in society. And then if that can actually be salient for essentially policy decisions and oftentimes the political climates of the day, then you can actually move to these spaces faster. And so the social scientists are also telling us that there may be more legitimacy to some of this type of information because it's actually coming from the people, not from a small group in a room that make a decision that we're going to fund X, Y, and Z. Let's just hear what the people have to say since they're working in the spaces. And so that's what we did. We asked people from around the world. We received hundreds and hundreds of questions from hundreds and hundreds and hundreds of people. And then we had synthesis workshops in different locations. And we align these with CTAC meetings primarily because this is a low budget, grassroots from the bottom up exercise. And we could get free spaces oftentimes to hold our meeting. And so from all of these individual synthesis workshops, okay, which were balanced with different disciplinary expertise, right? We tried to make sure we balanced for gender diversity, age diversity, including students at all of these meetings, and also included different sectors, right? So we had stakeholders from government, from business, and academia at the table. And so what I'd like to do is spend the next 3 or 4 hours, I'm just kidding, Alistair, going through some of the major themes that I've picked up. So this is my perspective. This is not me speaking on behalf of my colleagues or any of the co-authors of the papers that have been published and moving forward. But we do see things like global megatrends come up again and again and again in different ways, looking across the different 6 workshops. So how is urbanization impacting human and ecological exposures from contaminants? Well, let's think back to that SDG 11, right? And we're trying to reduce the adverse per capita environmental impact of cities. Think about municipal waste management kinds of issues. This is a really important goal, right? And it's an important goal because by 2050, 70% of all people are going to live in urban areas. We're doing work in Asia. Gosh, just by 2030, 22 megacities are projected to appear in Asia alone, right? What's happening is we're concentrating people in cities, and we're concentrating people in cities as we're increasing access to various types of chemical products. And we're doing both of those things faster than we're implementing environmental management systems or interventions to protect public health and the environment. That's the reality. And while I'm an optimist and I like to work with my colleagues to see positive, movement of knowledge forward, and let's make more sustainable decisions when we can, it's based upon credible scientific information. This is a big challenge because we're not going to be able to implement by 2030 Western advanced environmental management systems around the world. We have the technologies, but the challenges for implementation are great. Let's go to Hong Kong, where I've been working for the last few years. Really interested in Hong Kong, not just because I like the food and the people, but it's the 4th most densely populated place in the world. So we're studying sewer sheds, which essentially here's our Hong Kong view from the peak, essentially looking down to Victoria Harbor. And we're also studying landfills, right? The projection of increased solid waste in Asia, for example, and other parts of the world where you're seeing the emergence of megacities is really quite profound. I'm standing on a berm looking at the harbor where they're bringing solid waste into the landfill. And if you look over to my right, this is the picture essentially of the Wint landfill, which is one of the largest active, perhaps the largest active landfill in Asia right now, at least that we know of. And so this is Hong Kong, pretty well developed systems. They have liners in place. They're catching leachate. I mean, it's much different than perhaps many of these other rapidly developing parts of the world where we may not even have structured landfills, and certainly not liners. And those liners are basically capturing leachate that's basically being treated, okay? And that treated leachate is being discharged right out here, okay? Right off the coast. So they're bringing all their solid waste in on barges, okay, and they're processing over here. This is the wastewater treatment plant that's treating the leachate. So this all sounds really good, right? Because we have infrastructure in place, right, to capture the leachate from the landfill and then to treat it. Now the discharge from this leachate is going right into this coastline right here. I have a talented PhD student who's finishing up this year, Becca Burkett, and she had a Erlenmeyer flask that she was starting to filter of that leachate sample, and in 15 minutes it gelatinized on the laboratory bench. I don't think I need to get into technical terms to describe that the quality of the discharge is not awesome, okay? Now it's improved, and this is Hong Kong, where there's actually some fairly well-developed systems, unlike a lot of places that you see throughout Asia, through other parts of the world, where we just do not have that much development. And there's multiple antibiotics being discharged from this landfill leachate that actually exceed predicted no effect concentrations for the development of antibiotic resistance. And it turns out these inherent connections between environment and health come up over and over again throughout the Global Horizon Scanning Project, including related to antibiotic resistance. Because if we think about just looking at a couple of the compounds that we see exceeding those PNECs that some countries in Europe, my understanding, are looking at right now in terms of regulatory activity, we just look at the published information for erythromycin and we see that in Asia alone, that value is predicted to be exceeded 33% of the time. Erythromycin is a pretty important antibiotic, so is ciprofloxacin. Now designated as a critical antibiotic by the World Health Organization. If you look across all geographic regions, based upon effluent discharges and published information, we see 58% exceedances of that antibiotic resistance PNEC threshold put forward by the Larson Group for ciprofloxacin. And we're concentrating people in cities, unlike any other time in human history. We're increasing the access to chemical products, and we're increasing the concentration of the use of those products. And we're doing it faster than we're implementing environmental management systems, or we're able to implement more developed interventions. Other things that we see across global horizon scanning, you know, food, water, energy nexus comes up over and over and over again. Food production, shifting markets. Where are we going to grow our tomatoes in 20 years? Is a question that people ask sometimes. How is that going to influence risk assessment in 2050? Isn't that the question that you guys are somewhat going to be engaging? And then what about all this population growth? Did you know some people like fish and shellfish and aquacultured organisms? In fact, aquaculture, the blue revolution, is critically important to feed the world in the future. There's a lot of hungry mouths, right? Terrestrial-based agriculture in terms of the amount of arable land is certainly flattened, perhaps decreasing around the world. So aquaculture is going to be very important. At the same time, we want to make sure that we're engaging aquaculture activities, and you have professors here that have been working on this topic formally, right? So on one hand, you want to make sure that you're performing aquaculture in a way that does not cause environmental impacts in the surrounding areas, especially if you're in areas of critical biodiversity. But on the other hand, you want to make sure that you're not growing your products perhaps in contaminated locations so that the food safety associated with that product produced becomes a concern. Because, yeah, FAO tells us that we need a 200% increase in food production by 2050 in developing countries around the world. And we're already recognizing that just in a few years, 2/3 of the world is going to live in water-stressed regions, right? Risks in 2050. This is exciting. You guys are lucky. You get to think about this. This is cool. Oh, by the way, 80% of the world's sewage goes untreated. So think about that concentration of all the people, right? And the fact that we're also increasing access to and the concentration of chemical products, and that's happening faster than what? We're able to implement environmental management systems. Future risks. Let's go back to Hong Kong, right? So here we are, and by the way, I love Hong Kong. I love the people, I love the food, and I really appreciate the partnerships with the utilities that allowed us to do some of this work. My colleagues there that helped us make this happen. So I'm a curious guy though, and I said, what's that? And I said, oh, Professor Burks, that's where we grow our oysters, right there. So remember, they're discharging a treated leachate sample here. And so there's stuff in that aquaculture product. Good news is, doesn't look like anything, at least we tested, based on that have available toxicological information, ADIs, RFDs, this kind of thing, look to be terribly concerning. But on the other hand, we also see some of these emerging substances that we almost have no toxicological information for. And you only find what you're looking for, right, is a principle of environmental quality assessment and management, right? You only find what you're looking for. And this is Hong Kong, right? Pretty well-developed systems, right? But also not what you see in a lot of places where so many people are growing. And so we're thinking about water reuse, we're thinking about product safety in aquaculture, and we're very happy to be working with our colleagues, Jeremy Koppel and John Scarpa at Texas A&M University in Corpus Christi. We also see lots of questions related to environmental chemistry and exposure science. This I know will be of interest to some of you guys. And if you're dealing with any types of risks, you got to learn some chemistry, especially if we're talking about contaminants. And yeah, we were really fortunate in this project to have many chemists and engineers involved in providing their thoughts. And so if we're going to think about bioaccumulation, an area that's very much interested to me, because it turns out exposure matters, dose is really important. How does food web structure influence contaminant accumulation and long-term consequences? How does alteration of food web structure drive those kinds of risks? How can we develop better ways to characterize use, emissions, fate, right, in different temporal and spatial scales? Some of us in the room work with models, right? We must work with models. We also must understand the assumptions of all models, right? Should we be using far-field air dispersion modeling to understand risks in aquatic systems from point source discharges? No. The exposure piece is decoupled from the reality that organisms deal with extremes, not averages. How do we develop more advanced forensic approaches? Non-target analyses is really going forward. There's great promise. There's also some limitations. This is exciting space for sure. Because if we look at a number of the chemistry questions and exposure science questions that come up through global horizon scanning, we start seeing a consistent overarching theme that there's lots of concerns with the current environmental assessment processes. That's why I'm so excited to be here, because you guys are embarking on a way to think about moving the science forward over the next few decades. So on one hand, we have gotten pretty good at responding to questions and addressing issues. On the other hand, we really need to be thinking about what's coming up next. And so how do we develop better broad screening, analytical, for example, again? non-target types of work. We also see is that there's exciting times because the technology is developing so fast that we can learn from these other disciplines and apply new tools like non-target analysis, various types of molecular techniques to understand stress response relationships in exceptionally new ways. At the same time, we're seeing ecotoxicology and environmental toxicology, which has historically been perceived, I think, by some, and perhaps in the past, to some degree, rightly so, depending upon the application, as very descriptive exercises. Not anymore. These have matured to decidedly mechanistic sciences, where we're able to think about stress response relationships. At the same time, how can we do something in a faster, more efficient, with increasing predictive potential? We see high throughput strategies are moving forward, but we're not really getting the point of thinking about effects and processes that get really to those broader scales of biological organization and interactions among them. How can we incorporate new data, big data, eDNA, incredible, right? To improve risk assessment and decision making. In the United States, we're still based on 1985 guidelines for water quality criteria. On one hand, they're fairly well developed, they've been implemented. On the other hand, are we integrating around the world best developed scientific practices in our environmental assessment approaches? Absolutely not. There's legal, there's practical, right? There's pragmatism to being able to adopt and integrate new techniques, new knowledge into existing processes and systems. This is going to move, and it's going to move fast. What about multiple levels of biological organization? Thinking about in vitro, in vivo, read across, in silico, into coherent hazard assessment frameworks. We oftentimes always focus on exposure because we know without exposure, there's no risk. We are increasingly looking at the hazard part as well, knowing that we have opportunities to reduce the hazards of chemicals that we're concentrating in cities, unlike any other time in human history, faster than we can implement technologies to reduce and manage exposure. So there's two sides of the risk component, right? And opportunities to reduce risk on both sides. More and more concerns with current environmental risk assessment processes. Oh, by the way, most of the empirical ecotoxicology data is from species from North America and Europe. That concerns people from Latin America, Asia, Africa, basically anywhere south of the equator, or people that live along the equator. This is the Ananga. It can live in water at lower pHs than what are currently used in bioassay guidelines from Europe or North America. But it's culturally very important to Maori people in New Zealand. And it's also tasty for breakfast on whitebait toast with cheese. Other connections among environment and health come through harmful algal blooms. Algal toxins occur in multiple locations. This is a major threat to both public health and the environment, at least in some places. And we asked with some of our colleagues a few years ago, I mean, you're supposed to be thinking about what risks in 2050, right? Well, there's relative risks, there's risk trade-offs, and there's countervailing risks, and there's alternatives, and there's all these different elements of risk that I think can be fun for you to explore. Are harmful algal blooms becoming the greatest global threat to water quality? Kind of a productive kind of question, right? And it was a great kind of title for a paper. It turns out in some places, some cases, sometimes they already are. Because you know who doesn't care if there's a little bit of atrazine or chlorpyrifos or Prozac or copper or ethynyl estradiol or microplastic in the water? The 3 million fish that died last week of a harmful algal bloom. I think we just recently had I believe it was a Paranesia fight fish kill in Scandinavia. These are tremendous. I worked with something called Primesium parvum and have for quite some time. And one reservoir in Texas, 2 million fish in a couple weeks, decimating net pen operations for aquaculture along the coast of Denmark. Hundreds of tons of fish lost in fjords when it blooms. We need better models, right? We need to understand the assumptions of the model, but we need better models. We have a lot of challenges. Analytical standards are not oftentimes available. The quality of those standards are questionable. We recently published a paper on a new method for microcystins and other algal toxins in water and fish tissue, which is greatly improved because of just availability of new separation technologies and also labeled analytical standards. And we're embarking on a multi-year Oceans and Human Health Center based at the University of South Carolina, which has people working together across disciplines to try to understand risks to public health and the environment from algal toxins. So exciting to me, hopefully as you're excited to be engaging people across different topics going forward. How can we extrapolate effects across species based upon evolutionary conservation of biological pathways? This comes from the pharmaceutical kind of space, I think. But this kind of question comes up in multiple locations because you see historically ecotoxicologists understood very few mechanisms of action. I think back when I was a graduate student, I mean, I'm getting older as it turns out, right? It was a few years ago, but not that long ago, it seems. How many gold standard mechanisms of action do we understand in ecotoxicology? Not many. Not many. And we would also then have to look to human toxicology because that's where we had the best mechanistic information, and we would then develop testable hypotheses, and we would perform studies. And we had used things like medicines as positive controls, right, to understand underlying physiological processes. Comparative physiology studies do this quite a bit. And then, of course, we realized that we knew a lot more about pharmaceuticals than any other classes of environmental contaminants, even pesticides. Imagine what we could learn if we actually use things like drugs as scalpels to understand structure-function relationships. So Richard Braid, in some of his postdoctoral work with us, was looking essentially at the influence of sulfonamides, influencing folate synthesis, which is conserved, okay, from bacteria to higher plants, and it gives off this really nice biomarker, which might even be a biomarker of effect. There's not many biomarkers of effect that are out there, but certainly much more sensitive, and if you disrupt that step in folate synthesis, you actually cause structural integrity of the cell wall to basically break down. And it's markedly more sensitive than what you'd see in morphometric endpoints. Now, this is before we had things like the adverse outcome pathway concept that was put forward. We were trying to think about, is the target there, is the target conserved? We think about things like antidepressants, thinking about anchor 1 molecular initiation events now, and how that actually comes to essentially anchor 2s at individual, which is very important from a protection goal for threatened and endangered species, and population level, okay, adverse outcomes. So we start probing differences between things like Sprague-Dawley rats, fathead minnows, to understand the functional interactions in the central nervous system with common serotonergic and noradrenergic targets. We then start modeling through Ted Valenti's PhD work here, part of it based upon water levels. Instead of just measuring what's in the water, can we get to internal dose? That's what oftentimes matters to the organism. What's actually getting into the individual, right? And does that reach some level of concern? So now we can predict. There's hopefully getting better at that. And there's certainly a lot of work going on bioaccumulation of ionizables these days. But in this case, the adult male fathead minnow has slightly higher than, and then increasingly higher than, levels of an antidepressant called sertraline in its plasma. And those levels are higher than human therapeutic dose for sertraline. So at these levels, what you see is in the brain of the fish, you see a significant reduction essentially in SERT binding, That's exactly what you'd see in a Sprague-Dawley rat, or you, if you take a sertraline for a couple of weeks. So this would be an example of our functional anchor 1 molecular initiation event being conserved across species. And then that translates actually to an anchor 2 response, which we think is actually ecologically important. Now, we from a risk assessment standpoint, we're not always right there yet. But what we do find is that the control, fathead minnow, when the lights are on, is anxious and hangs out under a shelter. Why would a small fish hang out under a rock when the sun is out? Help me out here.
That's behavioral for fatheads.
They do. It's evolutionarily ingrained.
Yeah.
Because they want to avoid perhaps the largemouth bass, right? But if you load them up with enough of the antidepressant, that's not what they do, right? Right? Dark, they're exploring. Does this translate to the field? Are these ecologically important adverse outcomes from a behavioral standpoint? Who knows? The good news is that we actually have better technologies now to start thinking about some of these, perhaps, in other cases, maybe not as robust, but ecologically important adverse outcomes. And there's rarely any type of, say, for example, a behavioral measurement in a standardized guideline these days. But we can also use behaviors in interesting ways for environmental contaminants. This is some of Baylor Still's dissertation work. And what we see is that pharmaceutical companies are actually looking at things like zebrafish behavior to develop fingerprints for drug candidates. Stereotypical responses may be associated with certain types of molecular initiation events. So in a high throughput way, we could actually identify, perhaps using those fingerprints, underlying mechanisms that then can be probed. More expensive types of studies could be performed. So what if we took a Verhar et al. Type of categorization approach? What if we looked at, say, category 1, right? Here's our non-polar narcosis sort of example. And that's what happens in the zebrafish and the fathead minnow when they're exposed to 1-heptanol. Here's what happens when they're exposed to acetylcholinesterase. Okay, quite different. This is all moving in a stimulatory direction, right? In a stimulatory direction in both fish models. Can we start understanding, maybe not necessarily always for risk, but even for categorizing or understanding less understood substances for behavioral perturbations? Because that brings us to another theme that I'm going to close on that we commonly see across global horizon scanning. It's this idea of green and sustainable chemistry and engineering. And specifically thinking about how can we understand more, because at the same time, we've had advances in analytical chemistry and non-target. I mean, we have an Orbitrap and we know how to use it, right? I mean, proteomic, transcriptomic, all these different types of data flow streams. We've got terabytes of behavioral data, right? All these different types of data streams. And we haven't even talked about field or eDNA or, well, we also see explosions in silico computational chemistry in terms of application to different spaces beyond, say, drug development. Can we predict biological and physical chemical properties of substances to minimize environmental hazards? Yeah, it's happening. It's happened and it'll continue to happen because there are positive propositions oftentimes for companies that are engaging these types of activities. We're also seeing a lot of driving changes in terms of substitutions or eliminating substances in consumer products that are not influenced by regulatory activity, but are being demanded, for example, in cosmetics by consumers. We see these kinds of questions show up over and over again, including sharing information and data quality, systems. How can you have these diverse information flows, or even information that's been compiled differentially, for example, by businesses, by governments around the world for more traditional measures of exposure or ecotoxicity? How can we put that into collated systems, ensuring quality that can actually support development of more sustainable and safer substances? How can we get people thinking in the comparative risk assessment, life cycle analysis, and even risk-benefit analysis more closely together? Oftentimes this is occurring, but those communities were recognized as perhaps not always communicating and working together as closely as they could if we're focusing on identification and design of more sustainable alternatives. So there's lots of opportunities here. Maybe you'll think about some of these new directions. This is big business, lots of resources in terms of being committed from companies going forward to pursue things like green chemistry principle number 4. So where are we with the Global Horizon Scanning Project? Well, I've tried to take a few minutes today to give you some of the thoughts on the overarching themes that are kind of emerging, okay? And, you know, this is not a me exercise, this is a we exercise. Just like the projects you're going to be engaging over the next few years together requires the we. You have to focus on your work, you have to understand your methods, you have to drive deeply, but you're also going to have opportunities to interact, right, across spaces. That's exciting. And that's what we did, right? So my understanding is you might have already seen, who's this guy? Paul Vandenbrink. Oh yeah, Alistair Box. I don't know who these guys are. Anyways, they might be in the room. But the point is that here's a paper that's just come out in 2018 for Europe, looking at some of these priority research questions, getting a lot of attention. Really kind of exciting. It's never been done before. We're actually thinking together, right? Just like you're going to be working together. And this includes people from academia and government and business and different disciplines. So pretty exciting. Also from Latin America. Latin America, we're already seeing fairly major resource investments, millions of US dollars being committed by several organizations just in Brazil at several of the questions to move these forward. The North America paper, lead authored by Ann Fairbrother, Derek Muir, and Keith Solomon, is in press, should be coming out in August or September in environmental toxicology and chemistry. And we were fortunate to be able to present on some of these topics at our national academies in December. So what are we learning? Well, I think if we were to answer, dare I say, the questions identified by the Global Horizon Scanning Project, it could take a fairly significant investment. I think the world needs to spend $2 million on those questions. It's a big number. I think there's 2,000 dissertations needed to answer those questions. That's a large number. But is it? Let's think about this. The Boxall et al. 2012 paper in Environmental Health Perspectives has been cited hundreds of times and has helped set a global research agenda. I personally went through 2,000 abstracts for people that were publishing in this space and bin them into different categories. And one of the reasons why I was convinced that the Global Horizon Scanning Project was the right thing to do for the right reason is I found the same experiment being performed in multiple countries at the same time. We have global goals that are noble, that we agree. In a day and age where we can't always agree, we've agreed that these are important goals. Science should be repeated. That's part of the scientific process. But do we need the same study going on 7 different ways, the same ways in 7 different countries? And oh, by the way, when you see some of those studies going on in spaces where they didn't realize that it was a non-issue that had already been addressed. Think about the waste. Think about the opportunity, though, to become more efficient if we can think together. $2 billion is a large number. That 2,000 dissertations is a large number. But how many dissertations are defended every year? I've had 2 in the last couple months. Professor Boxall, it sounds like he's got 3 coming up. And so these numbers actually add up. What if we were to think together? I'm excited for you because over the next few years, you're going to be able to do that. And I do hope that the Global Horizon Scanning questions provide a useful resource as you're thinking not just about your projects, thinking about the broader landscape in terms of key questions that thousands of our colleagues have helped contribute to identify, right? And then as you move forward in your career, some of these questions are going to be as relevant in 5 or 10 years as they are today. Best wishes. Thanks again for the opportunity of joining you. And we hope to be in touch with you more over the next few years.
Thanks, Brian. Are there any questions? No? One there.
Brian, how will CTEC take this further? How will they bring this to the attention of the, for instance, the funders of research?
That's a great question. This is new for CTAC as well. Organization, I guess I'm a CTACer, you know, trained by some of the people that started the society years ago. But yeah, this is not something that we typically know how to do really well as scientists and engineers, right? We tend to do a really good job of doing research, training students, working on advancing the practice. We tend to take those types of exercise to conferences, publish them in journals, perhaps have symposia, proceedings, books. And so, you know, I think CTAC has been involved in trying to sort of market the materials a bit, but it's a relatively small organization that doesn't have staff dedicated to do this like other organizations. So what I would essentially say is that we can't just put this on CTAC. It needs to be something that all of us as community of scholars think about. And if you have ideas to translate these types of questions, help put them in the hands of the people that might benefit from them, we're happy to assist, connect you with whomever could be useful there. So I think it'll definitely be a village type of approach, but at the same time, the questions came from the bottom, and perhaps the best use of this type of information is to equip the next generation of researchers, the active professors, companies, you know, government agencies that are interested in the space. Any other questions?
Well, it's a comment really, since you focused on the sustainable development goals. I would like to mention, now I'm putting on the hat of integrated environmental assessment and management. They will have a focus on the sustainable development goals for the coming year, and ask for papers that focus on the sustainable development goals. So if we in this project think that our papers that will be coming up over the years are relevant for the sustainable development goals, that we should have this in the back of our mind, that this can be nice to this CTAC journal.
Yeah, one of the big challenges right now with the SDGs is that environmental quality is inherently required to achieve them, but it really intersects across these SDGs. And the SDGs is written, and we think about partnerships and public-private, all these different types of ways to actually move it forward. But environmental quality is so critical to being able to realize the SDGs. Right? I think that's the opportunity as we think through our research, and we think about essentially mixed phases, different connections between consumption and production and water and terrestrial systems. And so I would probably encourage the students here to think about those connections, right?
So I've got a question. So you obviously presented quite a high overview of the questions. Were there any sort of big differences geographically across the different sort of geographies?
Yeah, absolutely. In the areas where there's more developing countries, the questions are quite different. You know, there's questions that were identified in Latin America of high relevance to Africa. There are questions of high relevance in Africa that were relevant to Latin America. How often do we strategically coordinate colleagues to work together south of the equator? I think we have less resources, obviously, less existing networks. We've been doing that quite a bit between North America and Europe. Hopefully that will continue for the foreseeable future. But I think we don't do a very good job of actually having focused engagement related to what businesses might call emerging markets or what we would consider as countries in transition or under development. A lot of common issues. Asia, very interesting as well. Some of the questions are exceptionally sophisticated and pushing the science forward. Others reflect identifying challenges associated with those countries in transition emerging markets. Right? And so probably more similarities between Europe and North America and to some degree Australasia than the others. Much more of a chemistry focus in North America, but that just comes from essentially the engagement of American Chemical Societies, Pharmacochemistry and Agrochemicals divisions, which have got thousands of members and obviously made some significant contributions. So if you take these as a sum, it's a pretty incredible template. And if you're students, I think it's a pretty awesome opportunity to be starting graduate study at a time where you're at least benefiting from. You can ignore all of it, right? You can choose to say it's all rubbish. Who cares, right? I wouldn't advise doing that because it is always useful to think about what others are thinking and specifically identifying as important theoretical and translational research needs. Any other questions?
So how do we move towards, I guess, including countries or regions like Latin America in this type of research? Because I could see this project being extremely beneficial for places like that as well, but they just don't have the infrastructure at the moment for that. Maybe not the funding.
Well,
how do we move this? Like, how would our group be useful in a country like that potentially? Like, would they have students and the training already in place for a group like this to exist?
But well, as it relates to how your group might interact, that's really not something that I should comment on. Maybe a little bit later we can have a different conversation. But I agree that network grants are critically important. Some of the questions that we see coming from the developing regions are really related to capacity, right? Facilities as well. And these are still scientific, but it's almost research infrastructure and the ability to translate more effectively to the local regions. So if you look at some of the major challenges that I see as someone who's working on 6 continents, I can tell you it's mobility funds. It's how often can we see resources that can scale across country specific borders or even European Union borders. It's a challenge on one hand because perhaps voters don't necessarily like to see their resources going outside of a country. On the other hand, it's probably the large NGOs that must take these types of activities on to be able to really develop more of the bridge schemes, to be able to facilitate the exchange of information and yeah, so those would be some of the thoughts I would have.
The South American papers, the one that's had the most
Big impact.
because it's actually led to funding in South America, I think. Isn't it?
Absolutely. Oh, millions of US dollars have been put forward just to 3 of the questions, right? So this is, again, dare I say, you had a process that was inclusive, that was transparent, that was multidisciplinary, included stakeholders. So it's all bottom up, right? The optics on this were intended to be clean, okay? And they were, right? The entire exercise was literally, let's go to the people. And it took a lot of work from some of us. We didn't get paid to do this. We didn't have a big grant to do this. We essentially were trying to essentially learn from our colleagues and giving our colleagues voices. And I think that type of information has been invaluable in places like Latin America.
How now that you presented this very broad perspective and for example aspect which is inspiring, I wonder how can we then take into account the goal for economic development and the fact that this is also linked to So more, the better the economic development, the more chemicals we could use and use.
Yeah.
So how can we achieve sustainable development?
Well, okay, so I drank the Kool-Aid on green chemistry and engineering a long time ago. Didn't intend to, just like I didn't intend to study, down the drain chemicals. But when you become interested in urbanization and water and going through these processes, and you sample really at the time exceptionally well-developed wastewater treatment plants in Old Mexico. And they were built around Lake Chapala as a way to protect the lake. It's a living lakes World Heritage Site. There's a number of endemic chorales that are in Lake Chapala that support hundreds of local fishing communities. My newly calibrated dissolved oxygen meter could not make a measurement on any of the effluent discharges. So you had outstanding, essentially advanced, or basically secondary wastewater treatment infrastructure that was put in, but there's no operation and maintenance. Okay, so that's a practical reality of, did we think through from a systems perspective carefully enough? Perhaps for the individuals in this room, you're already becoming predispositions to become systems thinkers, even if you may not know what systems thinking is yet. We have to take systems approaches, no doubt about it. And I mean, green and sustainable green chemistry is not a field; it's more of an approach, right? Green engineering is not a field, but it's an approach, right? Although I guess maybe some might debate it's a part of environmental and civil engineering. But the point is that if you look at the Landrigan paper in the Lancet Commission, they take on this notion directly of the Quiznet curve, that we have this long-held idea in environmental economics that the development must come at a cost, where there's going to be less developed technologies that essentially only result in some sort of improvement and resource investment into waste management, public health, environmental protection, when the side effects essentially of the development are putting so much cost on the system that you've reached a developmental status, you now have the resources to be able to come back and deal with this. But there are technologies that are more sustainable, okay? And so I think if you look at the opportunities to implement existing technologies, if you think through the systems approaches, and if you think about the opportunities to fuel innovation through some of these like green chemistry, sustainable chemistry, and engineering spaces, oh yeah, I think it's really exciting. And in fact, I would probably place a nice wager that some of those types of approaches are going to be more effectively by 2050 in certain countries than to try to implement, okay, and enforce a Western type environmental management system with associated technologies in some places around the world.
With relation to this green chemistry, so you say we're putting people together, we're putting chemicals together. Do you think, you said something about less hazard? Do you think with green chemistry that we can have the same functionalities which society asks for with less hazard or with less degradability? And a second question, what do you think of seeking non-chemical alternatives instead of seeking more circular chemicals?
Yeah, so I think a couple of things. I've got a lot of thoughts on this. We're concentrating people in cities. Fact. That's happening faster than any other time in human history. Fact. That's happening faster than we can implement environmental management systems or interventions. Fact. We're also,
could we choose to?
Well, could we? Could certain countries actually do that?
China could.
China maybe has the resources and they're starting to make some progress, right? So, and there could be tremendous opportunities just for a large country like that to lead in innovation, no doubt. So, are we going to realize more sustainable environmental quality by moving forward in that space or moving forward in a space to, because, look, you're not controlling exposure if you're discharging poorly treated leachates from landfills and untreated sewage. 80% of the sewage in the world is untreated. So we move faster trying to implement that approach around the world, or do we try to implement other types of approaches and technologies? Well, it's not an either or, it's a combination. Without a doubt, there are always challenges achieving noble goals. The goals of principles of green chemistry are fantastic. The two least developed goals in green chemistry, basically principles of green chemistry, are goal 4 related to sustainable molecular design and also design for biodegradability. I mean, there's no doubt, I think that's pretty well held. Those are the two least developed goals. Then you have to look at, okay, can we take more of a systems approach and say, are there opportunities? Well, there are opportunities right now. Companies are doing this. Companies are making replacements. They're designing de novo substances. We have the Safer Choice Program in the United States, which is a non-regulatory form or function of EPA, which basically is a green, essentially evaluation system, which then, if the components of a product are identified as sufficiently lower hazard, they actually get a label that can be used for marketing. As one example, lots of voluntary activities by other companies, taking substances out of products, not because they have to, but because consumers are demanding it. So this is really kind of happening. Can you do this in all cases for all compounds? Well, there's some heavy lifting, obviously, that's going to be required as we understand some of the chemistries. But there's certainly low-hanging fruit and opportunities that we're seeing realized now, and I think we'll continue to see it realized. If you were to decrease the aggregate hazard space for a typical urban discharge in a developing megacity, that could be a way to control risk, right? Or certainly manage risk, especially if in that megacity you're not going to be able to implement some, advanced wastewater treatment technology in the next few decades.
Do you have any idea why society has such an increase in the use of these chemicals, and can we go for non-chemical alternatives?
Well, that's a pretty general question, so I think we'd have to look at specific uses. Right. So easy.
Do you think that communication is important for this kind of project? Because I feel very lucky to be in a project where supervisors really emphasize that we have to work together and share and think together. Do you believe that we need to try to to communicate that this is the new way we are trying to work together and think together?
Yeah, it's interesting. One, scientific communication, yes. Do we all need to be involved with this, and should it be more effective? Absolutely. There's all kinds of fake information that's coming out there, and people can have their own opinions, but when you start seeing the peddling of fake facts, right? Because the poor understanding of information. Well, we should be involved with evidence-based decision making when it relates to health and environment decisions, right? Food production. I mean, this is the reality. So we have to do a better job as scientists of communicating to the public. I don't think you should take that on perhaps without some training, right? And the good news is we have increased basically programs, different scientific societies to be able to improve scientific communication. I don't know how much we take that on voluntarily. Certainly as faculty or students, we're all busy, right? But we certainly have to do that. I think the communication more broadly to the public should involve coordination among scientific societies. But at least I could say that in the United States, oftentimes what I see is the only time that societies can be predicted to work together if there's some sort of legislation that is being proposed that would affect all sciences. Then you would have all these societies sign on to some letter saying that we support Bill X or we do not support this proposed activity. You do have examples of organizations working together here and there. But recall I was talking about the systems approach, right? We've really had a lot of reductionist thinking in science, right? I mean, I like to joke in some ways, it's kind of sad, is that the freshwater people get together with their friends and colleagues, and they have a meeting every year, right? And the marine people get together. And then there's the estuarine and coast folks. Don't forget the wetlands people, they get together as well. And then there's the groundwater people. Have you heard of the oceanographers and the physical oceanographers? And then we haven't even gotten into the people that work with contaminants. There's a sediments meeting, don't you know? So you can kind of go through how we've had to become more and more reductionistic and specialized. But at the same time, it's like I'll hear from a former student who works in a company where it's left hand and right hand. One side of a company might actually have exactly the understanding or the technology to be able to address some issue over here. But even within that organization, which might be smaller than, say, a country or an EPA or an UBA or whoever it happens to be, right? The communication is not always there. So, and it can be challenging, right, to coordinate in meaningful ways across these different groups. But the only way we're going to be able to move forward toward the Sustainable Development Goals and to think about assessing and managing risks in 2050 is to embrace more systems thinking, in my opinion.
Okay, so I've got one last question.
Yep.
So you've got 149 questions.
Yep. $2 billion, 2,000 dissertations, roughly.
So say we had 10 million.
Yep.
What would be the first two that you would tackle?
Well, I know what you'd like to do, but
No, not us.
yeah. Oh, for me?
Yeah.
The first two I would focus on, I think, are along the holy grail kind of space with chemical stressors. It's essentially looking at the forensic approaches with non-target analysis and interfacing that with computational chemistry going one direction, with essentially predictive toxicology and computational chemistry going in the other. And the reason for that is because I've made some computational chemistry friends, and I'm now of the opinion, the strong opinion, that all biologists, ecologists, toxicologists, whoever you are, find a computational chemist who's competent and have a conversation. Now, it may take 3 years of that conversation till you actually are really there, but I'm seeing tremendous opportunities. I have a colleague that's actually doing this work where he's trained essentially to design medicines, okay, for like lead development, but now using that space for the design of less hazardous or avoiding side effects of industrial compounds. It's happening. The cover of Green Chemistry last month tells part of his space, right? So I think those would be the two that I would focus on. This is just my individual preference. But if you can do that better, you can do all kinds of other things prospectively and retrospectively more efficiently.
Right. Right. Well, I think we should thank Bryan.
Well, thank you. Yeah.
I would suggest we now